All right, thanks everybody for being here today with us. My name is Seth Brown. I'm the Executive Director of the National Municipal Stormwater Alliance. We have a great bunch of folks today covering a lot of ground. Specifically, this webinar is part of the Water Use Action Plan, the EPA Water Use Action Plan, or WRAP 2.3.3, focusing on stormwater capture and use. Today's topic is going to be focusing on treatment standards. So that's going to be the focus area on that. Just so everyone knows, there's about 500 folks on here, or close to that number, that have registered. So really strong interest, and appreciate everybody for taking time out of their day to share this with us. We're going to be talking on this subject for the next 2 hours. And the other partners involved with this effort is EPA, of course, being obviously leading on the Water Use Action Plan, or the WRAP. We also have the Water Reuse Association, the Water Environment Federation, Renew It Research Center, and the Johnson Foundation at Wingspread. And all of this is tied together under this WRAP topic specifically. I want to cover a couple quick logistics for folks to be aware of. First of all, there are 3 handouts in your go-to, and we have, folks may not, we're all using different kind of platforms, Zoom and Teams and whatnot. This is GoToWebinar. There's a GoToWebinar app on your desktop. You should find the handouts area. There's 3 different PDFs available. One of those is the slides that are going to be shown today, and then the other 2 are just good reference material, and we may have some specific references to that. Another thing is that we will be recording, that we are recording this right now. This will be posted on the NMSA YouTube channel and other channels as well in the future. You'll get a link to this recording in the near future. And lastly, if you've got any questions to ask, we'd love to get some interaction from you. Look for the question part of your GoToWebinar application on your desktop. That's the best way to do that. We'll be taking those questions. A couple of us are going to be reviewing those and kind of handing them off, and that's going to drive the discussion today. So I'm going to, before we get going too far, I'm going to launch a quick poll so we can see who's on today. And as that's going on, Molly, I don't know if you want to kind of take things over and elaborate a little bit more.
I'm happy to. Thanks so much, Seth, and welcome everyone, and thanks to all of our guests. The agenda for today is going to flow according to the following key chunks of information that we'll share with everyone. First, we'll start with about a 10-minute introductory presentation to go over the topic in general. The second is a panel that will address the treatment standards for stormwater from the perspective of stormwater managers and groundwater managers. The second will address the topic from the perspective of the experts who are involved with the development of methods for determining stormwater capture and treatment needs. And then the third is about a 30-minute joint panel discussion where we'll bring both of those groups of experts together to talk about whether or not available methods adequately guide protective yet implementable treatment specifications. And this will be, the idea is to have an integrated discussion about topics like future treatment R&D needs and opportunities to support expansion and the advancement of stormwater capture around the country. So then we'll all come back together again. We'll end up with about 10 minutes for just some brief closing remarks and end at after about 2 hours. So that's the plan for the agenda. Thanks, Seth, for the quick poll. You want to go through that with us quickly?
Yeah, I mean, it's interesting to see. It's always nice to know who's on these events. We're doing so many of these today, and it looks like we've got a lot of folks from the public sector, which is great. Very helpful to have people in the field that are implementing and dealing with these treatment standards directly. And of course, we have a lot on the technical side too, on the private consulting side. So thanks for everybody for joining us. I just wanted to share that so that everyone could see who's on this event with us today.
Terrific. Thanks, Seth. And I will hand it over to David Smith, who is the Assistant Water Director at US EPA Region 8, who will go through an introduction to the issues associated with stormwater capture treatment standards. Thank you, David.
Well, thank you, Molly. I'll just mention that much as I love our colleagues in our Denver region, I'm actually in our Pacific Southwest region, Region 9. But for today's purposes, I'm wearing my hat as a member of the National Water Reuse team that was involved in developing the Water Reuse Action Plan that was issued about a year ago. I'm very happy that so many of you are joining us today to talk about a really interesting technical area of practice regarding stormwater harvesting for use. A little bit of background. When we released the RAP last year, we were trying to create a framework for national collaboration and action to support water reuse and integrated water planning. Working with a large number of partner organizations, we're trying to build our nation's capacity to recycle water better. Action 2.3.3 that Seth mentioned is focused on stormwater capture and use and trying to explore opportunities and needs to expand the use of stormwater capture and use around the country. We're trying to identify the key technical challenges in stormwater capture and identify some approaches to help build our capacity to better address these challenges. We're going to talk about one of the main challenge areas today. Our strategy under this action is to build capacity by working with experts and hearing from practitioners like you about your interests, concerns, and support needs. This webcast is the second in a series that are exploring these types of issues around stormwater capture that will lead up to a national convening that will take place later this year, where we're going to try to identify priority actions for future investment in the development of stormwater capture and use. Seth, may I have the PowerPoint, please? I'm going to take just a few minutes reflecting back a little bit on what you told us when you registered. And then we're going to talk a little bit about some of the basic issues around the development of treatment standards for stormwater capture and use. It will be a very high-level review because we didn't assume that everybody knows a lot about this who are on the webcast today. Next slide, please. So as I mentioned, I wanted to tell you a little bit about what you said to us when you registered for the webcast. I appreciate your doing that. First, I'll mention about half of you are from the West, and about a quarter from the East, and the rest distributed in between. Now, this slide talks a little bit about how you responded, about how you're determining your stormwater capture treatment needs now. About a quarter of you are using the standards developed by the state of California, often referred to as Title 22 standards. And then some of you are using other methods, including adapting the work of the Blue Ribbon Commission on on-site reuse, developing your own approaches, and in some cases, applying approaches that were developed for wastewater recycling. Interestingly, more than half of you said you're using other approaches, which is something we want to learn more about. Next slide, please. And we asked you, how satisfied are you with the approaches you're currently using? About a quarter of you expressed concern that these standards might not be protective enough for the uses you have in mind. A little more than a tenth of you thought perhaps they were too stringent for what you have in mind. And about a little more than a tenth were satisfied with what you have to work with now. Again, more than half of you mentioned you have other concerns, and I'm hoping that through your questions and comments, we can get a sense of the other concerns you have in mind that might guide our discussion about what we need to do to help you get more satisfied with the tools available to you. Next slide, please. So I wanted to just review some things that may be obvious to many of you. There really is a lot of interest in adding stormwater harvesting to the mix of ways that we can make the best use of our water resources around the country while addressing other priorities like water quality protection, flood control, and things like that. It's clear that stormwater can be captured and used in a lot of different ways. Irrigation, cooling water systems, in building toilet flushing and other uses. Can also be captured to help augment drinking water supply, to help augment groundwater aquifer resources, and to use for kind of green infrastructure needs around things like wetland development, stream flow augmentation, and things like that. As is the case with all water recycling, we need to make sure that these uses can be done safely. And sometimes that means we need to do treatment before it's used. But how do we know how much treatment is needed? Next slide, please. The process of determining fit-for-purpose treatment standards is complicated. Different uses of recycled water need different kinds of protection depending on how the people or aquatic organisms are exposed to the water and the kinds of pollutants that are in the water. To date, most stormwater harvesting, whether on-site, at the individual building scale, or at broader municipal scales, has focused on protecting human health from incidental exposure to pathogens in the water that can make you sick. However, there's also interest in using harvested stormwater in other ways, as we mentioned a little while ago. And determining where we most need to develop treatment standards that are appropriate for these different uses is a challenge. And that's really the reason we're here today, is to talk about those issues more. Next slide, please. Now, working on stormwater makes this difficult. As you know, if you work in the stormwater field, stormwater is very complicated. Stormwater varies a great deal in how much of it there is and its quality, depending on where you live, land uses, precipitation patterns, and how that stormwater is managed. Now, making it more complicated are factors like the presence of homeless populations and leaking sewer pipes that have potential to leak into storm drain systems. These add additional variability and complexity. What's more, stormwater management practices vary a great deal. And we know something about how effective those management practices are at filtering pollutants, but that knowledge is imperfect. Now, across the spectrum of questions about stormwater capture and use, we do have to rely on data to analyze it. And stormwater data overall are, I would say, somewhat limited. And we don't necessarily know whether the data we have are fully representative of the wide range of conditions that we're trying to evaluate. Now, altogether, this makes for quite a challenge to figure out what's the appropriate level of treatment when we are harvesting stormwater. Next slide, please. Now, I'm going to oversimplify this a lot, but there are some similar approaches for determining protection levels and treatment needs for water and for water recycling. I'm going to, as I said, sort of oversimplify the very difficult process to figure out how do you evaluate kind of dose-response relationships and then associate that with treatment that's necessary to reduce pollutant exposures to levels that we think are safe. The methods that are being used to look at stormwater harvesting are pretty similar to the methods that have been used to develop recycling standards for wastewater. And in many ways, the kinds of methods we use to develop water quality standards for other purposes. There's two basic approaches that we're seeing used in most of the US. The first is to create and apply endpoint target levels that need to be met. For example, we might conclude that the water would be safe for human contact if it's below a certain concentration threshold of a particular pollutant, like a pathogen indicator that we might select. Now, it can be difficult to evaluate if we're really attaining these endpoint targets because we have to rely on monitoring data to evaluate whether we're meeting them. And as we mentioned, stormwater data tend to show a lot of variability over time and place. So it's hard to really evaluate, are we meeting targets when we set them? It's also difficult, particularly when we're talking about human health and pathogen indicators, to know whether the indicators we're using are accurately reflecting the actual risk of exposure. And those folks that work on pathogen control know that there are issues with whether the pathogen indicators we commonly use are really discriminating indicators of the types of illnesses we're trying to track and the pathogens that cause them. The other main approach, it kind of flips the first approach on its head a little bit, and is intended to determine pollutant reduction needs to protect these uses. And as we evaluate the source water quality and our tolerance of risk to human health, this helps us figure out how people are being exposed to polluted water and what level of pollutant reduction is really needed to protect human health at the selected risk level. And this in turn informs selection of treatment technologies that are capable of attaining that level of pollutant capture. The log reduction target approach that you'll hear about more today is a prime example of that approach. And as I said, similar models to these are being applied to develop treatment needs for other kinds of water recycling uses and for other water uses, period. Next slide, please. The log reduction target approach is the one that most people are talking about when they're talking about protecting human health when we're using stormwater for consumptive uses. Much of the work to develop and apply this target approach has come from efforts to identify the treatment needed for different kinds of wastewater recycling, and in other settings to develop a framework for figuring out how to do safe on-site water recycling for non-potable uses. And as I said, most of the focus has been on pathogen control. It's difficult to use stormwater data to use these approaches because of some of the issues with variability of stormwater data and questions about whether it accurately reflects the complexity of stormwater conditions that we see throughout the country. For that reason, many practitioners have estimated human pathogen loads likely to be present in stormwater as a fraction of pathogen levels in municipal wastewater. It's kind of a surrogate indicator approach. There's a lot of research going on now, and you'll hear about some of this today, to try to improve upon the application of this approach for stormwater harvesting. And so our panelists will get into some of those issues and some of the work they're doing in this area. Next slide, please. So the question will arise, how well do these approaches meet our needs? We heard from the registrant poll that the answers were mixed from you. It's worth noting that decision-making on setting treatment needs for stormwater capture and other kinds of water recycling are being done at the state or local level. It's a very decentralized process at this point, which creates maybe some additional challenges in figuring out what's right in different locations. Some of the key questions that we've asked our panelists to address today are about whether these approaches really protect all the uses that we're trying that we have in mind for stormwater harvesting. We want to consider, do they adequately protect groundwater quality, where we are infiltrating captured stormwater to aquifers? We want to also consider how is captured stormwater actually being applied? Perhaps it makes a difference in whether, for example, a park is irrigated at night when there's nobody there, or during the day when they are. There's different views about whether the existing standards are too conservative and maybe unaffordable to implement, or maybe from other perspectives, not conservative enough. And finally, we really want folks to think about, where do we go from here? Based on the issues and the concerns that we're hearing about, what are our priorities for further research and development? May I have the next slide, please? So you'll see here listed a bunch of references for your consideration if you want to delve further into this. But I think it's time to get on with it. And as Chris Cuomo would say, let's get to it. So Molly, please take it away from here. Thanks, everybody.
Thanks, David. And I'm going to welcome our first panelist back. If you'll start sharing your webcam again for the first panel. I'm going to take this opportunity just to thank those of you who are sharing some questions using the question function. That is very helpful. We'll try to either address those real time through the experts or pull those into the conversation. And as we're having an interactive discussion with the panel, we'll try as much as possible to be tracking some of those questions and weaving those in that are most relevant. For this particular, as David was explaining, there's a lot of opportunities and some interesting challenges associated with these approaches. And so these next two panels are going to delve further into some of the issues that Dave raised at a high level. This first one is going to focus on bring our experts in to explore currently used practices to determine stormwater capture and use treatment needs and standards, and discuss how well these available methods meet the needs and address the concerns from the perspective of stormwater and groundwater managers in particular. We have 4 experts who are joining us on this panel. Katherine Dachinsky from Austin Water, Scott Taylor from National Municipal Stormwater Alliance and the Michael Baker International, Julian Bautista from Washington, D.C. Department of Energy and Environment, and Lori Council from the Texas Commission on Environmental Quality. So I'm going to ask each of our panelists to introduce themselves with a question. Please tell us how stormwater capture treatment needs are being addressed in your particular area and the viewpoint therefore that you bring to this conversation, and how well are those approaches meeting your needs and the needs of those project proponents in your region. I'm going to start with Katherine Dachinsky, Austin Water. Katherine.
Okay, thank you. Again, I'm Katherine Dachinsky, and I manage a brand new on-site water reuse program for the City of Austin's water, wastewater, and reclaimed water utility, Austin Water. We're a large municipal utility in Texas with just over 1 million customers. And the City of Austin has had watershed protection ordinances in place since beginning in the 1970s and further developed in the 80s. And these ordinances were put in place to mitigate the effects of urban development on waterways. They protect water quality in Austin's creeks, rivers, lakes, and springs, which ultimately supply our community's drinking water source. And they protect lives and property from flooding and erosion. The watershed protection regulations prescribe how individual development projects have to capture and then treat stormwater on site before releasing it to the natural environment. And the treatment that's required is focused on nutrient, metals, bacteria, and sediment removal. And these are pollutants that can really degrade a natural water body. If you fast forward to 2015, the City of Austin set to work on a 100-year water supply plan. And one of the strategies in our now adopted water supply plan is the on-site capture and beneficial reuse of alternative water supplies, such as rainwater, which we consider rainfall collected from a roof surface, and then stormwater, which is rainfall collected from ground surfaces, and then things like AC condensate and gray water and black water. In order to implement this water supply strategy, we as a city again turned to ordinances. And at the end of last year, in 2020, we adopted an on-site water reuse system ordinance. And this ordinance prescribes how individual development projects, again, need to treat these alternative water sources for beneficial reuse for non-potable purposes like toilet flushing and irrigation so that they're protective of public health. And the treatment that's required by this ordinance is focused on pathogens like bacteria, viruses, and protozoa, which is a bit different than the pollutants of concern from the watershed protection ordinances. And I should mention that these beneficial reuse standards were adopted from the National Blue Ribbon Commission's risk-based regulatory framework, which Dave mentioned and which will be discussed further in this panel. And so at this point in the City of Austin, the watershed protection ordinances are mandatory for all new development projects. And the on-site water reuse ordinance that just was adopted is voluntary. But moving forward, we're anticipating by the end of 2023 that this on-site water reuse ordinance will also become mandatory for certain development projects. So We as a city are going to need to work with our development community and other stakeholders over the next 3 years to reconcile these different ordinances so that we're achieving all of the stated goals for stormwater management. We need to continue to protect the health of the natural waterways that supply our drinking water and habitat for aquatic species. We also recreate in these waterways. And we also need to protect human health as we maximize our local water supply sources by collecting and reusing rainwater and stormwater in buildings. And so moving forward, we'll have to make sure our regulations are not overly burdensome for these development projects so as to be impractical or infeasible to implement. And then we'll also have to make sure that we can have integrated stormwater management systems so that we're not duplicating infrastructure that could have multiple benefits to both water supply and water quality. Thank you.
Thanks, Katherine. I'll move on to Scott next. Welcome, Scott.
Thanks, Molly. Again, my name is Scott Taylor, and I chair the National Municipal Stormwater Alliance. It's a 501c3 that assists MS4s in implementing their PDS program required under the Clean Water Act. I'm also the past chair of the California Stormwater Quality Association, which is the largest stormwater-focused association in California and probably the U.S. And I also currently co-chair the Transportation Research Board's Committee on Hydrology, Hydraulics, and Stormwater. And I've been a consulting engineer for about 36 years, and I'm based in Southern California. So I'm going to talk about my perspective is really from California. In terms of regulation, it's out in California's permits for infiltration of water. You have to have a unique item about California is that our permits are written by 9 different regional boards. So it's almost like having 9 different states within California. But for most of our permits, there's a fair amount of parity between them on the major issue. And for infiltration, you just have to have usually about 10 feet of separation between the water table, and you have to do some sort of pre-treatment like detention before you infiltrate stormwater. But the permits also say that you can't cause or contribute to a violation of a groundwater standard, and that's not super helpful for the permittees because obviously nobody knows if they're doing that. There's something like about 60 million chemicals that are commercially available in the U.S., and we don't know everything that's dissolved into water. So that's an issue. In terms of using stormwater for some of the flushing or irrigation, we're really hobbled in because there's no state accepted treatment standards or technologies for direct non-potable reuse. Everybody kind of melts to Title 22, Dave mentioned, which governs wastewater, or recycled wastewater, reclaimed wastewater, which probably isn't the right standard for stormwater. But the fact that there is ambiguity, that there's no state standards, just introduces risk people into the whole program. So am I, as a developer or the residential, commercial, industrial, going to put in a non-potable reuse system when there's no state adopted standards? Probably. And I'd say the other major barrier is really economics. Even in California, which is water state, I think, by standards, I looked at my water bill in preparation for this webcast and found that, hey, at my tap, 0.4 cents a gallon for potable water. That's just the commodity charge, our lowest tier. It doesn't include any fixed costs, but that's really low. So if you start looking at capture, storage, distribution, and any sort of treatment of stormwater, unless it's going to be mandated, you've got to come up with a cost of less than 0.4 cents per gallon, which is really difficult because some of the storage that we've done in urban areas, it's very difficult to get the storage of stormwater down below $1. And you can just do the math and see how many years it would take you to pay for the cost of constructing this facility. So I'll stop there. There's a lot of issues around water in California, no shortage for sure, but hopefully we'll more of those as this goes on.
Great, thanks, Scott. We'll try to dig into some of those issues a little bit more here in a moment. Next, I'd like to go on to Julian Bautista of Washington, D.C. Department of Energy and Environment. Thanks for joining us, Julian.
Thank you, Molly. I'm Julian Bautista. I'm the branch chief for Stormwater and Green Area Ratio Review for the District of Columbia. In our department, we enforce stormwater regulations, and we've had stormwater regulations in the district since the 80s. Prior to 2013, our requirements were only detention and peak flow reduction and the first flush treatment. In 2013, we changed to a retention and detention based standard and requirement. From that, we have a plethora of green infrastructure practices that we promote. Stormwater reuse is one of them. And with that, new development and redevelopment are required to capture for stormwater. So in 2013, when we introduced the idea of stormwater reuse, we had used an idea called the tiered risk assessment. And I'm a civil engineer, so the public health people in the audience, I don't know very much about tiered risk assessment. And for the civil engineer designers in the DC metro area, that was a really hard concept for them to understand. So in 2020, we ended up adopting the National Blue Ribbon Commission's log reduction target. So kind of a simpler way for civil engineers in the area to design and treat for the end use of the stormwater reuse. And so, the Department of Energy and Environment in the district is not a utility. So we work with our utility partners like DC Water, and we work with our public health department to see, what kind of items that they want us to look out for when implementing and providing guidance to civil engineers. And as of right now, we've had a pretty good run of using the log reduction target. We had sent out our document for public comment in the last 2 years, and we've gotten a really good grasp on what the development community has been receptive to try and use. And within our own agency, it's allowed us to be more innovative when going out into projects in the public spaces in the district. I do want to discuss we have this interesting kind of intergovernmental dynamic here in the district. Our water is delivered by the federal government, by the Army Corps. DC Water checks for potability standards, and then DC Health makes sure that the water quality standards are met throughout the entire system. So I am working with multiple federal agencies and local agencies to make sure that, whatever stormwater capture reuse is meeting public health standards. Overall, we've had a really good run. Current projects that are lined up are bus washing facilities for the local transportation authority, which I think will push the envelope on water reuse. They are on site constricted areas where they have contaminated land, so they can't infiltrate, stormwater infiltration practices, but are permitted to do reuse. So using that kind of design constraint really pushes the envelope for us here in the district. Thank you.
Julian. Lori, Council, thank you for joining us. Lori's with the Texas Commission on Environmental Quality. Thanks, Lori.
Well, hello, thanks, Molly. Hope everybody's having a great afternoon today. So I'll be having the view of a groundwater manager, namely the Underground Injection Control, or what's called UIC program. This is a program that's authorized under the Federal Safe Drinking Water Act, and in Texas under the Texas Injection Well Act, better known as the Texas Water Code. The UIC program, we've had primacy for it at my agency since 1982. And just stormwater reuse is a subset of the UIC program focus that I'm going to present today. So UIC Class 5 injection wells include aquifer storage and recovery, or ASR, and aquifer recharge, or AR wells. and projects. And so note that not all aquifer recharge projects use injection wells. Some will also use recharge basins, other methods. So recent legislation that was enacted in Texas in 2009, House Bill 720, allowed for unappropriated state surface water, and that includes excess storm flows, to be used in ASR and aquifer recharge projects as a beneficial use. This legislation included groundwater quality standards and requirements for the subset of aquifer recharge wells or injection wells. So the water quality standard for aquifer recharge wells is focused on the resulting quality of water that may be produced from an aquifer that is recharged by an aquifer recharge project. And it's that focus rather than on the quality of water being injected into the project. So it's not really a pre-treatment focus at all. And it's the same groundwater quality standard for aquifer storage and recovery projects. And again, multiple sources can be used, but today's focus here is about stormwater or not so much rainwater harvesting, but stormwater and excess flows. With regard to the aquifer recharge projects, my agency has to consider whether introducing water into a receiving geologic formation will alter the physical, chemical, or biological quality of the water or the native groundwater to a degree that would, and I'm going to bore y'all with some real specific language, to a degree that would render that groundwater produced from the receiving geologic formation harmful or detrimental to people, animals, vegetation, or property, or that would require an unreasonably higher level of treatment of the groundwater produced from the receiving geologic formation than would be necessary for the native groundwater to render that groundwater suitable for beneficial use. So the statute and the rules that my agency adopted recognize that all aquifers are not the same, and the quality of water in aquifers varies from place to place. And not all aquifers have pristine native groundwater quality. The statute and rules also recognize that all aquifers are not this, or excuse me, that groundwater is used for many different purposes, not just for drinking water, but also for agriculture, industry, et cetera. And, aquifer recharge can be used for things like preventing subsidence. So basically, this focus puts the burden of evaluating the potential for impacts to native groundwater quality from a proposed aquifer recharge project or an ASR project on my agency as well as the project applicant. There's no real prescriptive set of standards that exists. I mean, the projects have to be done within the bounds of the Safe Drinking Water Act. But there's, a huge amount of variability. So the water quality considerations for aquifer recharge and ASR projects must include, among other factors, adequate characterization of the stormwater or the other water sources that are used for the project for injection, adequate characterization of the native groundwater quality, and also evaluation of possible geochemical interactions between the injected water and the native groundwater in the geologic formation. So what this presents is essentially a multivariate water quality equation. And the definition of variables is both technically challenging and costly. And I would say the most difficult variable is adequately characterizing the water that's going to be injected or infiltrated, especially if the source is from storm flows. I'd also like to note that because of the newness of the legislation, that the state is really kind of on the front end of project development. So I'm sure that potential project operators would be very interested in what folks have to say on how you might better characterize the stormwater quality and figure out if it's a good match for the aquifer that you might have for a potential storage zone. Thank you.
Thanks. Thanks, Lori, and thanks to everyone for the great intro perspectives. I'm going to dig into a couple of the points that that you all alluded to, and also try to pull in some really interesting questions that are emerging in the questions function from our participants. I'm going to start with a bit of a general question about these issues around how much treatment is needed for different purposes. And I'm going to start with Scott, a question from you in particular. One of the questions that had come up had to do with whether or not, or how important it is rather, to identify treatment needs for pollutants beyond pathogens. And embedded in that is sort of a question, a broader question of how much is enough. I'm wondering if you can help us to think through how you have addressed that challenge. And then I'll open it up to others to weigh in, since each of you come from a slightly different perspective on that question. So Scott, why don't you start? Looks like you're not unmuted, Scott. You want to try unmuting?
Sorry. Let me know if I'm breaking up
go.
too much. That said I was. I can, my camera is bad, so just interrupt me if so. In terms of, identifying pollutants beyond pathogens, I think it's important. I really take to heart what Lori said. We just don't know enough about what's in stormwater. As I alluded to before, there's well 60 million chemicals that are commercially available, and we discover these, every once in a while. There's a big, rush of activity currently right now. PFAS and FAS are the big kind of pollutants du jour, but we have a lot of pesticides, microplastics, the new oxidizer from tires, D, PP6. There's so many chemicals out there that can come in contact with stormwater, and so many of those are dissolved. And if they're dissolved, they're most likely going to have a pretty good chance of going directly into an aquifer. And so then you're going to be potentially impairing the use of that aquifer. So I think it's extremely important, if you're going to infiltrate stormwater, that you really do a good job of characterizing it, and you really understand that it is going to match the future beneficial use of the aquifer. Because just essentially right now, I think what we're doing a lot is just translating our surface water problem, our surface water quality problem, into groundwater, and just kind of whistling past the graveyard, if you will, and letting some future generations take care of that. So a big issue, and again, I don't think that we have enough information to know what's in stormwater to address it yet. So that's one of the major challenges.
Let me open it up to others on the panel, other perspectives on this particular issue of and understanding that there are a lot of emerging contaminants. Scott mentioned some, and that from the different perspectives we need to address, but how do we also do that while making sure that we are making these opportunities accessible and financially viable, et cetera. Anyone else want to weigh in on this question of how we best target that sort of fit for purpose and or other approach to treatment? How far to go with treatment?
This is Lori.
Lori,
I'll
go
just
ahead.
take one kind of sideline look at it. So there's a number of different land uses out there. There's a number of uses for water and dealing with recharging aquifers, specifically with stormwater. And I think, if folks look at kind of like the wellhead protection program, what are the sources in the area? What's likely to be in the water? And then just another general observation from practical operational standpoint for injection wells. And again, I'm focusing on, not surface infiltration as much as direct injection. But removal of suspended solids is necessary to effectively get stormwater and collected water effectively into the ground and into aquifers through wells and also through basins. And that way you're not clogging up your well and clogging up your formation, which can be fatal to a project. And so I think if folks can be looking at, what kind of bigger infrastructure kind of pre-treatment, so you can get some removal of the suspended solids. A lot of other contaminants are going to go with that. And so that doesn't address a lot of things that Scott brought up, but just from a practical standpoint, something to be considered.
Any other comments from Katherine or Julian, especially about how we address some of the challenges, not just what the challenges are, but also what you're seeing as some of the mechanisms for addressing them? Katherine or Julian, anything to add there? Okay, Katherine?
Sure. Yeah, I guess I can sort of address from the, kind of the on-site treatment approach that we've taken at the development scale that, we are addressing some of these contaminants known and unknown by setting up these sort of stormwater controls and letting the stormwater kind of sit in the sedimentation basins and removing as much as we can from the stormwater before it's released to the natural environment. And then in terms of the kind of the beneficial reuse standards, I'm not a super expert on it, but I know that the Blue Ribbon Commission and their expert panel, and maybe Sybil and the other panelists can talk about this more, that they looked at some of these other non-pathogen type of contaminants and said that they're not as great of a risk to the public health when you are treating and reusing the water for like toilet flushing and irrigation. You're not ingesting the water, and so the risk is less to human health.
Yeah,
Go ahead, Julian.
And for the District of Columbia, when we receive construction and new development plans, and they propose doing water reuse, stormwater reuse, we kind of look at the stormwater that's, what kind of land uses are happening there, what kind of maybe potential industrial uses. Some of the challenges we have in the district is a lot of people want dog parks and then they want that runoff to be reused, and that can be very challenging for us to see how do we eliminate some of those pathogens from that water source. So there's always questions, and there's always this design iterative process between my team and the development community about what is the best way to treat this. Are there other methods? What is the rest of the nation doing?
Great, thanks everyone. And let me just say apologies. There are some terrific questions that are starting to come up in the question window. And if anyone wants to try to respond to some of them real time, I encourage you to do so, because we're going to have to move on to the next panel. I'll also try to bring some of those questions into the third panel where we're all interacting together, and we'll prioritize a few of those. But thank you all. Thanks to all of our panelists for kicking things off for us here. I'm going to ask you to turn off your webcams, and we'll move on to panel number 2. So everyone on the second panel, please share your webcams. And I'll remind everyone that we now are moving on to the views from the method developers. And this is a conversation among experts who are involved in determining the development needs and methods for stormwater capture and use, et cetera. And there are some, you can bring in to your comments, your opening comments, some really interesting questions now that are emerging in the exchange for this panel. So again, we have 4 experts with us that I'll just introduce briefly here, and then open with some general comments about the perspectives that you're sharing. Sybil Sharvelle is with the Colorado State University. Brian Bernados is with California State Water Resources Control Board. Michael Jane is with US EPA Office of Research and Development, and Anita Anderson is with the Minnesota Department of Health. So a variety of perspectives that are coming here to us to talk about the perspective from the developers and the method developers, treatment and standards and method developers. How are each of you approaching developing and improving methods to guide treatment needs for stormwater and rainwater harvesting? And as you look forward, what are some of the future challenges and opportunities that you're seeing in identifying implementable treatment standards and expectations for stormwater and capture and rainwater capture and use? So I'm going to start with Sybil to kick things off with your introduction and opening comments on that general question. Sybil, thanks for joining us.
Hi, thank you. Sybil Sharvelle from Colorado State University, and I have experience with working on development of stormwater regulation guidance through my interaction with the National Water Research Institute panel that developed the guidance that was then used by the Blue Ribbon Commission that we've been talking about here already this morning. So I worked with that and am currently also working on another panel that's organized by the National Water Research Institute to advise California Department of Water on regulatory guidance for decentralized water systems. So all of those efforts include stormwater within them. So that has been my primary area of focus within the stormwater area. I think that some of the challenges that exist with stormwater in particular is that it is so difficult to measure and quantify and estimate how much pathogen load we would anticipate at a particular location. Stormwater quality is highly variable across locations, but even at a single location over time, depending on the stormwater event and hydrologic characteristics that occur between events. So that's a real challenge, I think, that is related to stormwater. However, stormwater is shown to be a really substantial water source. When it comes to these different alternate water sources, stormwater can really work to offset our demand for potable water quite substantially. So there's a lot of opportunity there. And I think that some of the guidance that's come out through the Blue Ribbon Commission has provided opportunity for growth and expansion in stormwater projects. And I think that we can continue to refine and improve the current methods to better fit regulator and project needs.
Sybil, we'll move on to Brian next. Welcome, Brian Bernados.
Hello, I'm Brian Bernados. I'm with the state of California Water Board. I'm in the Division of Drinking Water. And as that, I've been a public health regulator for over 28 years in California. So I've dealt with drinking water, where stormwater is obviously a source to drinking water supplies, and I've been involved with recycled water, and now we're getting into stormwater officially. We implement the Title 22, as was mentioned by Dave Smith, but that's was specifically intended for recycled municipal wastewater. Some people have applied it to stormwater, but that was not, necessarily our guidance. But now we're going to write regulations by 2022. We're using Sybil and other experts, including Michael Jahne, to assist us in writing regulations that will be out by 2022, and they're going to follow and be based on the National Blue Ribbon Commission effort. So that will be black water, stormwater, gray water, and roof runoff. So we will have different targets for each of those. Probably there'll be a lot of projects that I hear about are a mixture of all those. And so that's probably one approach, where if stormwater is mixed with gray water or black water, then you're treating everything to a good standard, and it probably makes it more affordable. One of the things I point out is our current not, Purple Pipe Title 22 requires daily coliform monitoring, which is a big expense for a lot of small systems. And that's what we've heard, is that could be, quite a bit because of the sampling and taking it to a certified lab, and could be $50,000 a year. So the operating cost for that is pretty expensive. Whereas by putting in good treatment over the long run, it's probably going to be cost effective with our new regulations. And so I think it's probably going to be a local decision, and our criteria is going to be depending upon local agencies implementing it. So, I don't know how much it'll be done where I am in San Diego, because they're focused on indirect polar reuse and direct polar reuse, but other places like San Francisco, they're definitely focused on these decentralized on-site water systems. Thank you.
Thanks, Brian. Michael Jahne, U.S. EPA Office of Research and Development.
Yes, hi, I'm Michael Jahne. I'm with the EPA Office of Research and Development here in Cincinnati, Ohio. And I've worked on the technical side of things to develop the risk models that ultimately were picked up by the Blue Ribbon Commission. I've been mentioned a couple of times during this panel. And so I can just take this opportunity a little bit to talk about our reasoning behind the wastewater dilution approach and why we think that's a good way to go, and also some of the challenges associated with that. And so I think, as others have mentioned, that stormwater quality variability is really the issue that we encounter both within a site and across sites. And so in order to develop uniform standards, it really becomes challenging. And even trying to bin out land uses, it still becomes very challenging to really develop specific targets for different types of applications. And so we thought that a good way to address that was to recognize that human wastewater is likely the driving risk in urban stormwater collections. That might not be true other places, but in an urban environment, it seems like human wastewater contaminated stormwater is going to be driving a risk. And so that's why we decided to say, if we can take these different dilutions of wastewater as our stormwater quality, that's sort of a simplistic way that we can get around that question of how variable it is. But in doing so, we also specified two different treatment targets, one for a low dilution of wastewater and one for a high dilution of wastewater, which then of course creates another challenge, because now the question is which of those targets is appropriate for each site. And so I think now the path forward there is really to develop tools that people can use, developers and other people who are interested in promoting these systems, to try to estimate which dilution of wastewater is most appropriate for a given site. And so that can use things like land use, obviously, sanitary surveys, the local asset conditions for the wastewater infrastructure, things like that can help them to figure out which of these benchmarks they should be shooting for, rather than trying to really measure their way out of the problem. Because as others have said, that is going to be challenging. Of course, there might be some validation measurements that might be required, but hopefully we can find a different path for people to estimate where they fall. And also say too that even though we're kind of focusing on pathogen risks, because that is on-site reuse, non-potable uses, really that is the concern there. I will say that the risk-based approaches could be applied to chemical contaminants as well. They have certainly been done in the past, and depending on your end use of interest and your scenario, if you're talking about aquifer recharge, there may be chemical risk are more important to you, maybe ecological risk are more important to you. And so I think that there's opportunities to use risk-based approaches in other types of scenarios beyond the one that we're talking about here.
Thanks, Michael. And Anita Anderson, Minnesota Department of Health. Welcome, Anita.
Thank you, Molly. I'm Anita Anderson. I'm with the Minnesota Department of Health, another drinking water person like Brian, and also a member of the Blue Ribbon Commission. So at our agency, we have a role in protecting public health. And then as drinking water people, we have an interest in sustainability for drinking water sources, both in terms of quality and quantity, as well as their business operations. And there's many more entities in Minnesota working to advance stormwater capture and use. I do want to just mention, that I really like to look at treatment standards in a bigger context. They're really just one piece of the puzzle. There's many other ways to kind of control the safety of reuse systems. So what we're really trying to do with our approach in Minnesota is set up kind of an entire support system, or a structured process for stormwater capture and use, such as we have for drinking water or wastewater. So that system would include things like resources to help implementers, maybe in design. It would include planning and integration pieces, education and training for system owners and operators, and then the guidance or regulation where appropriate, and then also oversight and funding options. So in Minnesota right now, we have an ongoing interagency and stakeholder effort to try and develop this system on a statewide basis. But if we want to get into treatment standards, our interagency team agreed that the log reduction target approach is both practical and makes scientific sense. And we've also seen it successfully implemented for drinking water and wastewater reuse. On the other hand, we did hear from stakeholders there's still some confusion about how it works. I think in both water and wastewater applications, it's really kind of behind the scenes, and it's been a little bit more at the forefront here. And we also heard concerns from our stakeholders that the data may be used to develop those targets were not from Minnesota. And are there differences here in the Midwest, whether it's our climate that's colder or has different rainfall patterns, or maybe our land use is different, or maybe we have a lower number of combined sewers, and do these targets need some adjustments? So we were lucky enough to have some unique funding opportunities where we've been able to partner with researchers to gather some Minnesota-specific data on stormwater pathogen content and see how it lines up with the things the other researchers here have talked about. And thanks to a skilled risk assessor in our department, and with, again, help from the researchers here, we've been able to develop the expertise and methodology to develop site-specific targets as we need to in our state, whether it's based on different sources or exposures or what we're finding in the stormwater. So I think that's going to really offer us a lot of flexibility going forward. But I should mention that most of these treatment standards are voluntary in our state at this point, unless you're doing reuse for an indoor use that falls under our plumbing code. These things are not currently regulated. And so kind of as was talked about before, we did have a mandate initially to do a study of the different approaches and make some recommendations, but we don't have that Federal Water Reuse Act, or even at this point state legislation to regulate these uses. And so it's been a little hard for us to have the structured venue and to have a really good conversation with, that's a big number of stakeholders, whether it's multiple agencies at the state and local level, the implementers and others. And it's been hard to have a process where everybody feels satisfied that their voice is heard and where we can kind of decide who's making the decisions to help us progress forward. And people have already mentioned, I would say, stormwater maybe isn't particularly challenging in its variability, but in my work with both groundwater and surface water, I think its pathogens in general are variable and unpredictable. And the monitoring takes a lot of time, and the methods we would really want to use are pretty expensive, and we can't use them all the time. And in addition, the health impacts of these organisms can sometimes be hard to trace, so it's hard to really gauge the true impact. But I do think that if we make a little bit of a shift, both for the agencies in terms of maybe getting out of our silos a little bit and doing some work we're not used to doing, as well as stormwater practitioners, maybe being open to a new way of monitoring and oversight with these targets, that we can go ahead with water reuse that's both safe and offers a lot of benefits. Thank you.
Thanks, Anita. I'm going to slightly adjust our first question to take into consideration a series of questions from the audience that addresses, I think, the intersection of two different issues. One is there's been several mentions of different approaches, obviously, to treatment needs. And there's a question about whether, the assumptions embedded in each are more conservative or more expensive than other approaches. But throughout, regardless of the approach, there is this embedded assumption that we're hearing that you're using approximations and assumptions rather than real data. There's a lot of questions coming in about the reliance on these assumptions. So I'm wondering if from your different perspectives, if you can address that very directly. where you see that going, recognizing the limitations, how do you correct for some of those assumptions? Can we talk more about whether or not you feel that these different challenges of both measuring the needs and are also developing treatments, how do you address this fact that you're largely relying on assumptions and approximations rather than real data? And is that potentially going to be changing, or are there opportunities to improve that? Sybil, why don't I think I warned you I'd start with you on this first question, slightly different than the one we discussed, but perhaps you can kick that off, and then I think each panelist brings a slightly different perspective on that. So I'll start with you, Sybil. Looks like you need to unmute. Thanks.
Sorry, I forgot to unmute. And Michael Jahne is going to be the best, I think, to answer this question because he's very familiar with the various assumptions that were used since he was so involved in the mathematical modeling that went into this. But I'll still go ahead and take a first take on this, which is that there is a lot of data out there on stormwater microbial quality. That data was reviewed in detail for the effort that we used to develop the dilutions for sewage in terms of sewage dilution or wastewater dilution that we would expect to see in stormwater, which range from basically 10 to the minus 1 to 10 to the minus 3, or 1/10 to 1/1000th. And we did look at, and particularly Michael's group, looked at all of that data and found that the data on microbial quality in stormwater falls within those range of dilutions. So while there are definitely assumptions, I think there are less assumptions than what a lot of users perceive. There was informed data that actually measured human pathogens in stormwater that informed the dilution ranges that were selected. And as Michael explained previously, there were pragmatic reasons that we recommended the dilution range because we felt that it was a more simple way for users of the log reduction targets to kind of identify where they may fall within that range. There are all sorts of assumptions embedded in exposures and both exposures and presence of pathogens that may be in any particular water source. And I'm going to let Michael talk about those.
That Michael paused himself. I'm just going to ask you to follow up. Okay, go ahead, Michael.
No, I said the wrong button. The first thing I want to say in respect to that is that at least we have transparent assumptions, and so within the risk modeling, we delineate, in these peer-reviewed articles, exactly what assumptions we're making and justify why we're making those assumptions. And so you can track back exactly how we calculated all of the LRTs that we've recommended, and so that's transparent and it's science-based. And the other nice thing about that too is that as we do generate new data or we come up with better approaches, we can update those models to incorporate that information. And then that's very much what California is currently doing. They're reviewing our work, but also seeing if there's anything that needs to be updated based on newly available data. And so I think that's really one of the advantages of the risk-based approach is that you know where the standard comes from, and you can if you think you can challenge it for a certain reason, if you think that your site has lower exposure or you think that your site has higher quality water, then you can talk to your regulators about that issue. I mean that's an advantage here in terms of risk-based approaches in general. And where you look at the indicator-based methods, if you adopt the rec water standard, for example, now you're just throwing out. Now there's no scientific basis for that number. It's just a number that someone else has used for something else in the past. And so I think that we're being more rigorous by doing this. And I also think it's nice because it can achieve a set level of risk. And so you start out with a goal. And so you say, I want my goal of a certain limited number of infections that I'm willing to accept. And then you essentially can work backwards from there to determine what the treatment requirement should be. And so it really does achieve a certain level that you can select of what exactly you want your outcome to be. and that's really what drives your treatment. And so I think transparency and adaptability is one of the key advantages there.
Oh, you're muted. Molly, you're muted.
Thank you. My turn. I just want to dig in on one point you made. You mentioned the indicators. So can you and or Sybil address more directly the use of microbial indicators and how well they work when we're concerned about other pollutants in the stormwater? That has come up. Any comments on how those indicators are working? Yeah.
Sure. I'll go ahead and start there. And I just wanted to follow up on what Michael said, is that in addition to those assumptions all being there in the peer-reviewed literature, there was a lot of discussion amongst the expert panels and the researchers that contributed to that effort that we all reached consensus on those very well documented assumptions. Now, moving on with the problem of indicator organisms. Indicator organisms are indicators of fecal material. This is particularly problematic with stormwater, where much of the fecal material that enters stormwater is animal fecal material that doesn't necessarily contain human pathogenic organisms. So indicator organisms, while being a good and acceptable, let's say, measurement of human pathogens in, let's say, domestic wastewater, where we know the source of pathogens is primarily from humans, it's very problematic in stormwater, where we have mostly animal fecal material that contributes to the pathogens. Now, there are other sources of human fecal material, and we've found human infectious pathogens, obviously, in stormwater, which is why we guided the treatment in the way that we did for log reductions of those pathogens. However, the indicator organisms are not well correlated to human infectious pathogens, particularly in stormwater.
Yeah, and I'll just add to that too, the other challenge with these indicators that we're traditionally talking about bacterial indicators. And so whereas the risks are generally driven by the viruses and protozoan pathogens that are present. And so there's automatically going to be a disconnect there between the pathogen classes, particularly when you start talking about treatment. And so if you're reducing coliform bacteria to a certain level, then maybe you are managing bacterial risks, to a certain extent, but that does not address the other types of pathogens that, again, are probably going to be more important from a public health standpoint and probably going to be more difficult to treat.
And maybe, Michael, just to ask you to sort of stay on the hot seat just for a minute longer here, knowing that what we've heard from everyone is that there's huge variability. That's part of what makes stormwater treatment a challenge. Can you reflect on the role that EPA could or should play at the national level in helping to inform local decision making about the selection of treatment needs? Is there more that can be done, and or what is that role that you think is appropriate as you look forward?
Well, I think the one thing that the EPA can and is doing is through the Water Reuse Action Plan, which is part of this, with this webinar is part of these types of conversations we're having, to really serve as a central place where people can have these conversations about what needs to be done and share best practices and challenges and all of that. I'm from the Office of Research and Development, so I can't really speak to the policy side of things, but I think that just facilitating these types of conversations and really putting water reuse in general to the forefront and stormwater reuse specifically, I think that's really an important role we can play.
Great. Let me open it up, Brian and Anita. Any other additional thoughts from your unique perspectives, more at the state level on these issues? Anything that you would add from your regions that are very different, and give us some interesting insights into the perspectives at a more state level?
Well, I'll just go. So yeah, I just agree with what Michael and Sybil have been saying, and I think the approach is good and scientific, and that's what we liked about it. And what I do think it was, we were happy to be able to take some data in our own state and just make sure it kind of fit somewhere in the realm of those assumptions, which it did. And I guess the other thing, based on my experience with groundwater and surface water, again, I don't want to discount the value of just looking at a situation and kind of seeing what you think about it. So if you know that a certain area has really old sewers or the dog park or whatever it is, those visual cues and kind of knowledge of the area can really lead you to which tier you should be in and what your assumptions should be. And overall, it does seem like a much better approach than just using the indicators for the reasons that others have said.
Great. Brian, anything further from you on that?
Yeah, I'm in agreement with all the other panelists. Having some bounds is helpful. So it basically means you're somewhere in between there. So it's going to be probably a local decision. And from the data that I've seen, if it's a very urban environment, then it probably has a lot of wastewater contribution. If it's less urban, I mean, obviously in the more pristine areas, you're not going to have a lot of the same human contaminants. And in California, there's a lot of conjunctive use where there's actually infiltration basins of stormwater in the more pristine areas that are used for drinking water. So it really is going to be a local decision. And then I wanted to say something about the emerging contaminant issue. I don't think that's really a big concern, in my opinion. I mean, the data that I have seen, and I have seen some data from Santa Monica, it didn't have a lot of chemicals in it. It did have a little bit of the perfluoridated. They're not regulated yet, so we'll have to keep, I think just the perfluoridated chemicals are just everywhere in our environment, so that could be an issue. But as far as a lot of the regulated chemicals, those didn't seem to show up. Nitrate, of course, and so you need to be aware of that if there's a lot of nitrogen or nitrate, but that's mostly animal husbandry and things, or leaking septic tanks. So I think the focus in California is going to be on the pathogens and not on the chemicals. We're not going to include that in our regulation. And I did want to clear up that our regulation is not going to require the daily coliform if we're in this risk-based. So that will be a big difference. It'll be more treatment-based and log targets. And if you're interested, I'm going to be part of the water use symposium. There's going to be a whole section, and Michael's going to be in that section too. So we're going to talk more about those in March if you're interested in that symposium.
Thanks, Brian. Can any of you address, as you've heard, there has been a lot of interest in groundwater within the context of this conversation. Can anyone address the issue of whether soil has been considered and how much it adequately filters some of the pollutants before the stormwater reaches groundwater? And any work that's been done on that, and or whether the approaches consider the soil character?
Well, let me just say, in California, we have regulations specifically for groundwater recharge of recycled water. And we have seen that, many projects in Southern California that have demonstrated what's called soil aquifer treatment of chemicals, including the nitrogen species is biodegradable, depending on your depth to the groundwater. So, if the groundwater is really shallow, that could be an issue. But even, over time, the natural bacteria does grow to reduce most chemicals. Most chemicals are biodegradable. Unfortunately, the perfluoridated are not. So that, again, that's still an issue. That will not degrade. It was designed not to degrade, so that's just a bigger picture issue for everybody. But most chemicals we have seen that are in recycled water get reduced, even like nitrosamines and other volatile chemicals. So with enough time, that certainly has been shown to degrade within several weeks to a month.
And Brian, are you differentiating between the wastewater and stormwater when you are developing the groundwater treatment standards?
Yes, it's specifically for recycled wastewater. But what I'm saying is that will have the higher amount of chemicals in stormwater, and so if we see it being degraded by natural, biodegradation in the aquifer, then it certainly would apply to stormwater.
Okay. Great. All right. In the interest of time, I'm going to ask the other panel to join us now for this third integrated panel. And that will allow me to pose a couple of additional questions to everyone that could be relevant. So third panel, or first panel, please share your webcam. We'll bring everyone all together at the same time and address some of the remaining questions that we have. I'm going to open with one that does build off of a question from our audience. And this is in particular, I think, timely because we have seen that the new Biden administration is really emphasizing climate priorities really right at the outset. And we understand that stormwater is one of the ways that we are seeing sort of manifestation of some of our climate impacts, our climate change impacts. And so one of the questions was whether or not climate change is a factor in how you've both, been thinking about both the needs and challenges associated with treating stormwater. Has anyone been addressing that issue directly in the work that you're doing that would like to kick off that question for the joint panel?
Well, let me just say, I think in California, that's why a bill was passed that requires us to develop this criteria, and I think that's been an emphasis of the current governor, is to encourage, sustainability in many different areas, and stormwater is one of them. Recycled water, gray water are all parts of the pieces where, in California, we've experienced long periods of drought that come and go, and we keep growing no matter what, just by natural, population growth. And so, we're looking to use all the resources, and instead of, importing water from, many miles away. I live in San Diego, and my water's coming from Colorado, and so instead of coming all that distance, if we can use local water, it's more sustainable in general.
Yeah, Molly, this is
Any
Scott
other
Taylor.
perspectives on how to address? Yeah.
Yeah, I would say that, we don't know. There's not a lot of consensus really on what design storm we should be using for green infrastructure. Are we being protective by what we're doing now, treating the first portion of runoff events and things like that. And it's much more difficult with climate change. I think that there's consensus that it's going to be, much more intense events going in the future than what we're seeing now. So that's to probably stress the infrastructure that we're putting in now and make it more difficult. But I think that's an area where there's a lot more work needed to understand it. We know that, in the past in engineering, we kind of base everything based on stationarity, looking at what has happened in the past to predict how it's going to operate in the future. And I think that that concept is now being rethought, and we'll have to see where it goes. That's going to be an interesting problem for us to tackle.
Great. Anyone else want to weigh in on that? How we think about and take climate change into consideration when setting both standards and thinking about the needs. Great. Okay. I'll move on then. So one other question I wanted to address to the full joint group before I open it up to some of your observations or any questions that you have been thinking about as you hear from some of your colleagues, is this question of how much, so a lot of what we have talked about had to do with relying on effectiveness of different treatment methods and alternatives and estimates and assumptions, et cetera, to evaluate whether we're doing enough to be protective. Can anyone address the question about whether or not we should or can rely on monitoring of discharges or other mechanisms to be able to sort of double check? Is that being done? How, can that be done efficiently and effectively? How is that informing some of the thinking and or making sure that we understand protectiveness? Anyone want to comment on that question?
I can go
Okay.
ahead and take a start there.
Yeah,
So,
go ahead, Sybil. Thanks.
I think that a lot of the problems around monitoring of discharges or effluent from a particular treatment system that's set up for stormwater capture is that there are a lot of the same issues that I already discussed related to the starting quality and variability of that in stormwater. In addition, it can be extremely expensive to be monitoring indicator organisms on sometimes a daily, or I mean, even if you wanted to monitor them every couple of days or week, it's still a tremendous expense on a project, and it doesn't provide real-time information on performance. This is the reason that the expert panel that informed the Blue Ribbon Commission guidance recommended going with the approach of designing treatment systems that achieve particular log reduction targets for virus, bacteria, and protozoan, and then designing systems that use validated technologies and doing perhaps some in situ testing of those systems to ensure that they're performing as they should, and then setting up kind of online monitoring of surrogate parameters that indicate when those systems are not performing well. So I'm of the opinion that having extensive monitoring requirements, particularly of indicator organisms, is both expensive and not highly informative in terms of how systems are actually performing. And that rather we can rely on some more online real-time measurements of surrogate parameters that tell us about how the treatment systems are performing.
And I guess I would say that I think we need to keep looking for problems in all of these systems, just because everybody's talked about how variable stormwater is. And I think we need to be vigilant. I'll give an example about a year ago, we had a 319H grant to look at runoff from roadway. And just thought, well, it'd be interesting to see, since cars have catalytic converters and catalytic converters operate with platinum and palladium, let's see if there's any platinum or palladium in the runoff. So we took some measurements and found that indeed there was in stormwater runoff from roadways platinum and palladium present, but there weren't any standards for either of those metals in the EPA Gold Book. So, and I think there's a lot that we need to just be vigilant for, because there's a lot of potential pathways, chemicals in the environment that aren't monitored for. And so we need to keep looking for issues and problems to make sure that we understand that we're protecting public health.
Thanks, Scott and Sybil, on that one. I guess there's maybe a bigger picture question I want to pose to the group, everyone, to hear your sort of latest reflections on building off of what both Sybil and Scott said, that, you know, given how much we don't know, the costs of trying to better characterize, and the cost of being protective in the face of uncertainty, is this really implementable? I mean, how do we do this in a way that really is implementable and cost effective, given so many uncertainties and so many challenges, and the needs to be really diligent about understanding the uncertainties. Anita, I'll go Anita and then Katherine.
I mean, I think to some degree, once you've committed to some layer of treatment for microbial pathogens, that you can meet a broad range of targets with that device. So once you've committed, again, to a decent UV system or chlorination or whatever is appropriate, you can get a lot of log reduction with that, or maybe you can make adjustments to, run your irrigation system in smaller chunks of flow rate or something, so that you're maximizing your investment in that treatment and can get a lot out of it. There's some pretty powerful treatments out there. So I think we can work within the uncertainty and still remain relatively affordable and implementable, in my opinion.
Yeah, and I guess just to add to that, in Austin, we have kind of the unique experience of having wide-scale adoption of rainwater harvesting reuse systems in particular, especially for outdoor uses, really before we had any regulations in place, or we just sort of said, yeah, you can do it and you can spray it all over and we think it's fine. Now there's more of a push to bring this water indoor for toilet flushing and things like that. And we have had some customers just choose to do that on their own. And again, under our previous, the plumbing code is where our system design standards were for these reuse systems. And the guidance, it said, you need treatment to do that, but it was not very clear what level of treatment you needed to do that. And so, but we would have systems go in that would have filtration and then, UV disinfection. And if you look at the Blue Ribbon Commission risk-based regulatory framework and the LRT, you really would end up with a very similar treatment system under that new framework. And so I guess intuitively, before, designers knew how to generally treat stormwater for reuse for toilet flushing. And now you have science to back it up, and now we're going to be requiring this additional monitoring of the system, and that's just going to give us, as public health regulators and program administrators, more of a guarantee that the systems are operating and being protective of public health. But we're just seeing that that's kind of already what the practice was for these types of systems. So I do think that they are implementable and that people understand what the needs are.
Thanks, Katherine. Julienne.
Yeah, I just want to add on that, the district is unique that we have these stormwater requirements in perpetuity. So when a stormwater reuse system goes in, 1 year after construction, we go back and check and see if it's operating to its ability. We go back every 3 years after that. So there is this continuous feedback loop potentially about whether these practices are working, whether there's been incidences within that structure or within that exposure levels to individuals operating the end uses. And so I think, our system, it's imperfect, but I think we are adapting to how we can, effectively manage our stormwater. And we are working towards having that feedback loop continuously going on. So having that in our regulations really gives us a lot of room to work with.
Go ahead.
Yeah, this is Lori. Just from a Texas state perspective, it's a big state here, and it varies from very wet, water-rich climate to very dry deserts. And so, I think a lot of folks, they may not have a lot of money, they may not have a lot of experience, and they want to make use of whatever resources that they can. And so I think I'd put a challenge out to have a better, more available, useful literature and body of knowledge, or access to other projects, information from other projects, so that folks can really gain from the experience of others. And so anyway, It's not really any kind of high-tech thing. It's more of a general concern for trying to facilitate projects or potential projects where they could happen.
That's a great segue, Lori, maybe to a question for all of the panel about, looking forward, what can we do, both in terms of R&D and sharing information, et cetera. Obviously, a lot is being done with respect to measuring and evaluation that could help inform others. How, and how do we make that more available so that others can learn from and ultimately decrease the costs of the protective measures that are that can be available. So other thoughts on looking forward, R&D needs, other needs that can help to improve and or lower the costs of the methods and the alternatives available. Scott.
Yeah, I think, one thing that we need is an urban water master plan. We've got these three sources of water, drinking water, stormwater, and then reclaimed water. California's invested a lot of money into reclaimed water infrastructure. And we're talking really about a source of water that's directly competitive with reclaimed water in California anyway. And we really want another capture, storage, and distribution system and have to monitor that. We have reclaimed water, which we're really awash in the winter in California, which is available at a price which is about the same as domestic terms of, at or at the sprinkler head. I don't think that we don't do a good job. California, we have these integrated water plans, but they don't really look at stormwater, and it's because it's kind of siloed. And what is the best use for stormwater in the urban environment? I don't know the answer to that, but I think that using and reusing the water locally, like Brian mentioned, the city of San Diego is going with this direct potable reuse, I think is good because you've got those systems in place, they're highly monitored and we understand them. And then maybe for stormwater, using it for infiltration and also releasing it into creeks and streams, we're really big on maintaining the hydrologic cycle as it was pre-development. And augmenting then this local use water and wastewater might be the best way to go. So I think, again, to answer your question, having an urban water master plan to look where stormwater fits in with these other sources of water that we have would be interesting.
Great. That's terrific. Thanks, Scott. Other perspectives on this? Sybil, go ahead.
Sure, thank you. So with respect to stormwater quality, I think that certainly one need which Michael and many of the other panelists also discussed is guidance on how one could select in this range of log reduction targets, like we've talked about, related to the sewage dilutions and for stormwater. There are data needs. I think part of what needs to happen is we need to really synthesize the data that are out there. Anita and the group in Minnesota have collected a lot of data recently on stormwater microbial quality. There is a good data set out there. We have a project funded by Water Research Foundation currently that's looking to synthesize that data and see if there are particular characteristics of either infrastructure, land use type, climate that could guide towards selection of log reduction targets within that particular range. That having been said, I do still think there's a need for more data nationally on how various infrastructure and land use types and climate impact stormwater microbial quality that can kind of help improve this guidance on where to select the log reduction targets.
Any other ideas about real opportunities if we were to focus on R&D needs in this area to help both make it more implementable, more effective, and or less expensive?
I guess we've talked a lot about the microbial side, and I think there's some brief mentions of kind of the exposure side, but if we can minimize the exposures, that's the other way to reduce your treatment needs. So say a lot of the reuse projects right now, or a number of them in our state, they're meant to be public education projects, and so they're very visible, and they're trying to use the water for really visible uses, but we can save a lot of water with some more invisible uses. Basic landscape irrigation that happens at night, or is drip or really low spray, and that can really help minimize the exposure, so we can again reduce the treatment needs. And again, we're using estimations for those exposures for other things like toilet flushing or more public irrigation strategies. So that's one area. I will put in a plug for EPA. I mean, I think the RAP and the RAP platform is a great place we can start sharing some of this information, and that's going to be really useful going forward. And then I just wanted to emphasize what Scott said about the planning piece, and make sure that we're out talking with the water utility and the wastewater utility and the stormwater managers, and really being smart about how all this is fitting together.
Yeah, Michael, do you want to say anything? And I might also welcome David Smith to come back in, and Dick Luthi as our closing reflections. Anything? It does seem that EPA is working, diligently through the RAP on this topic, and that there might be opportunities to establish a clearinghouse of sorts. David or Michael, would you like to share anything on EPA's role in helping to create a resource?
Yes, thanks, Molly. I did want to mention that in addition to having this national convening in partnership with the Johnson Foundation later this year, we've just decided to partner with a number of organizations, some represented here, to develop a national stormwater capture research and development strategy. And the idea is that we believe that this will help inform future investments where research funding is available, and it sort of help identify what the priority needs are to further develop some of these technical approaches and methods. And so we're hoping to build upon some of the needs and recommendations that are coming out of this webcast and some of the work to follow to inform that strategy, so that when we spend more money, and there will be more coming to invest in the water reuse area overall, that we do so wisely. So I just wanted to mention that's one of the future things that we're actually going to start working on in March.
Thanks, David. Michael, anything you want to add, and from the perspective of obviously ORD and the work that EPA is doing on more the research side of things?
I will say, David's really been a leader here, in terms of the stormwater actions that we're working on. But within our research, in ORD, we really are looking at these questions, particularly for on-site systems. Is these, like as Sybil mentioned, how do we try to estimate the pathogen load that you have in your water? And so that's really the approach we're taking. I don't think that, like I said earlier, I don't think this is really going to be a problem that we can measure ourselves out of. I think there's just too many different bins that you have to consider. And so I think really developing the right tools on both the modeling side and the measurement side to be able to assess your stormwater quality with the appropriate indicators is really, that's really the way to go.
Great. And is there anything, let me ask the question about sort of looking forward, research and development opportunities specific to groundwater, since that has been a topic that's been of concern. Anything that we need to be doing proactively to ensure that our groundwater is being adequately protected that we're not already doing? Okay. Go ahead, Lori.
I don't have a direct, I'm not going to be saying this directly, but the Groundwater Protection Council recently published an opinion on their webpage, talking about beneficial use of stormwater or a source of contamination. And basically looking at maybe more holistically, looking at this issue from not just a silo of the Clean Water Act or a silo of the Safe Drinking Water Act, but to look at it more broadly. And so I can send a follow-up link to that opinion. It's Groundwater Protection Council, national organization of state groundwater directors. So anyway, just thought I would bring that up.
And if I may, I would add, Lori, that there is a separate action under the water reuse plan that's trying to focus in more detail on issues related to groundwater protection associated with different kinds of reuse. And so we're trying to kind of cross-fertilize across actions to kind of bring to their attention, the folks working on that action, some of the needs that have been identified here in the stormwater management space.
And Molly, I would just say, monitor, looking at our groundwater resources and monitoring them. As I model, or we monitor for only a fraction of what's out there in the local universe. So we don't know, so we keep looking.
Great, thanks, Scott. So emphasis on monitoring of our groundwater resources. Thanks. So last just question, in the spirit of this looking forward, any last comments from any of our panelists about anything that you're very excited about or you really think is an opportunity that we need to emphasize in order to make these methods more implementable? Okay. Sounds like we have exhausted this perspective anyway on the challenges and opportunities and latest in a series of conversations that we have underway focusing on advancing stormwater capture and use. So thanks to everyone for this really interesting perspective from a range of geographies, a range of expertise working on these issues, and sharing that out with the rest of the country. A lot of other people who are interested in these issues and helping other people who are grappling with them. I'm going to shift now to introduce our final commenter, our final guest expert. Let me introduce you to Richard Luthi, who is Stanford University professor and the director of Reinventing Our Nation's Urban Water Infrastructure, which is an NSF research center. Thank you, Richard, for being with us and for offering some closing remarks and looking forward with an eye towards where do we go from here? What's next? Welcome.
Right. Well, thank you very much. This has really been a stimulating discussion. One perspective I see here is that we had folks from across the country, California, Minnesota, Texas, Washington, D.C., and what we see here are somewhat different views about what do we mean by stormwater capture and use. And well, that's to be expected. If I wanted to pick up a few thoughts, though, the issue of stormwater quality kept coming up again and again, and I'm going to say that there's needs to be more than just focus on pathogens. So that's clearly important for public health. But maybe perhaps we're coming to grips with that and can deal with it. But like Scott said, we have these chemicals du jour, and we want to be sure that we're not overlooking something that's going to come back and cause problems in the future. We need to understand, at least from where I sit, that there's a difference between on-site stormwater use and urban stormwater. And the urban stormwater is the runoff, from the city hardscape and all. And there's an opportunity for us to capture and use that water but clearly you pick up lots of different contaminants, and we need work on that. In terms of standards, you know, Katherine had an interesting point about how do you reconcile standards. In her state, she was talking about, you know, you have standards for watershed and standards for on-site. Well, you know, if I'm talking about stormwater for the water supply, maybe it sort of melds those two. Lori, you mentioned standards for aquifer storage and recovery, which is good to pay attention to. And you mentioned suspended solids removal. So Sybil talked about surrogates of performance, and one thing to think about, you know, what goes along with suspended solids removal? Could that be a surrogate for some of these chemicals we might be thinking about? Anita, you mentioned our national standards applicable everywhere. Well, we'll have to think about that. And then getting back to what does it all mean? I think we have to pay a lot of attention to what's the role of urban stormwater in our water supply master plans. Now, water supply master plans are really big out here in the West, where we don't have enough water all the time. And what's the role for stormwater? Frankly, in San Diego, you don't have good aquifers, you don't have much rain. But as you go further north, just into LA, the stormwater capture could be maybe 25% of their future water supply. But there are questions there. And, you know, examples of dry wells, we heard example of Santa Monica, but a dry well is essentially a hole in the ground. And if I put quote, a lot of holes in the ground, am I going to be causing problems with my urban aquifers? Well, these are all things to work out. And I think that the sorts of things that David Smith is talking about looking at how to get a national dialogue going, building capacity, understanding the opportunities, and working on how to best build local and regional capacity. That should be our goal going forward. Now, as we conclude here, we will be posting the webinar along with a summary report later. There'll be future webinars about stormwater capture and success stories, and about developing and funding multi-benefit projects. By the way, multi-benefit is so important here. For public acceptance and funding, if you think about multiple benefits, then stormwater capture projects can almost, well, they sell themselves and almost pay for themselves. And so, you know, understanding the value of that is really important. Coming up in March, we'll have the Water Reuse Association National Symposium, and stormwater capture and use will be a part of that. And some of us are participating in that. And then later, a national convening on stormwater capture needs and opportunities with support of various groups and hosted at the Johnson Foundation Wingspread. So I see this as an area that I guess you would say is sort of underexplored or underdeveloped, because we focused so much in the past on water and wastewater. We have funding mechanisms to address those. We pay for those services, but we have stormwater, which with capture and use can provide so many benefits and can contribute to our water supply, that it's an area for us to pay a lot more attention to in the future, and to make sure that we're doing this in a way that meet our goals and are protective of our groundwater resources, and also don't detract from flows that may be needed elsewhere, like in urban streams. So with that, I will pass it back to Molly. Those are my, or Seth. I don't know who's going to have the last word, but I thank you all for participating, and our panelists in particular.
Yep, great. Thanks, Dick. And I don't know if Molly wants to, it's chiming back on, but I just wanted to say again, thanks for everybody who joined us today. We had a lot of interest, and you know, we continue to have interest on this. And as Dick said, you know, we've got participants. We cover topics across the nation as a national organization, the National Municipal Stormwater Alliance. We're looking at things in a broad way and a broad perspective. So having different perspectives from Minnesota, Texas, and California, obviously, which is leading the way in many ways, is very helpful. And I think it reflects the fact that this is becoming a national issue. It already is, but it's a growing issue. And that's in our first webinar that we had about 3 weeks ago, maybe a month ago, that talked about this. It was very clear, just the level of interest, not just in California, but beyond. And because California is leading the way, others in water-rich areas, I'm in the Washington, D.C. area. Clearly, this is a topic of interest. We had Julienne from the District Department of Energy and the Environment here talking about the same thing here. So we have a long way to go. And I think forums like this are really helpful to push this dialogue forward. Dave Smith from EPA talked about there's going to be more research in this area associated with the RAP and beyond. So be on the lookout for that. Again, as Dick mentioned, this has been recorded. This will be posted. If there's any questions about anything that's been covered here, you should have contact information. You can contact me. That should be available at the registration link as well. So I think I'm going to wrap up now. It's not often you wrap up these webinars early, but I think it's not a bad thing for people to get a couple of minutes of their life back. So I appreciate it. I hope everyone's doing okay across the country. I know there's been a lot of struggles with the weather lately, so hopefully everyone's hanging in there. And we're looking forward to more discussions in the future. So with that, I'm going to wrap things up, and I'm going to hit exit. Thanks a lot, everybody. Thanks for being here.